Evaluate the limit if it exists. The limit as x approaches 4 of x squared minus 7x plus 12 all over x minus 4. Here we have a rational function, so we could try and use direct substitution, except when we substitute in 4 for x, we end up with 4 minus 4 equals 0 in the denominator, and so that's not a part of the domain, and we can't use direct substitution. But we might be able to simplify things here, and in fact, that numerator looks like it might be factorable, so let's give that a shot. If we want to factor the numerator, we need two numbers that have a product of 12 and a sum of negative 7. Well, that's going to be negative 3 and negative 4. And once we factor that, we see there is a common factor in the numerator and denominator that we can cancel out. And it's perfectly fine to cancel out x minus 4 in the numerator and denominator because we're looking at the limit as x approaches 4. So that means we're looking at x values near 4, but not equal to 4. And so when x is not equal to 4, these factors are not equal to 0, and so it is legal to divide by them. And so then this becomes the limit as x approaches 4 of x minus 3. And there we can use direct substitution. Plugging that in gives us 4 minus 3, which is equal to 1. So in the end, that limit is equal to 1. Whenever you see a polynomial in a rational function that might be factorable in a situation like this, it's a good idea to try and factor it because you might have a factor that cancels, which then simplifies things, which might open the door for direct substitution.